All right, Josh, here is lesson 79. I'm trying this with a tripod, and we'll see how this works. So, and I don't know how to pronounce it, Adv Math theorem and roots of complex numbers. So the very first thing that we're going to talk about is if you have two complex numbers that are written in polar form. So for example, if you have R1 CIS theta 1 and you're multiplying it by R2 CIS theta 2, what you do is you take R1 and R2 and you multiply them, and you write CIS, which I'm not entirely sure. I know that's the cosine and the sine, but I don't know the terminology for that. And then you take theta 1 and add it to theta 2, which you have been doing already. So now it's saying, let's just let Z equal R CIS theta. Okay, so if Z is equal to R CIS theta, then Z squared is going to be R CIS theta times R CIS theta. So using what we know that's going to be R squared CIS 2 theta, because you're adding those two. So then let's go one step further. If you cube it, then you're just doing R squared CIS 2 theta times R CIS theta, and so put those two together, you get R cubed CIS 2 theta plus theta is 3 theta. So you can continue this on indefinitely, so that we find out Z to the n is equal to R to the n CIS n theta. So when you multiply it out, that's you end up getting R to the n CIS n theta for whatever you have. That's called Adv Math's theorem. So we'll just do example 79.1. Go ahead and try it, and then just check back with me, pause it, and here's how you solve it. 2 CIS 30 degrees to the 5th power. It's going to be 2 to the 5th power CIS 30 times 5. So it's going to be 32 CIS 150 degrees. Pretty simple. Okay, example 79.2. Find 1 plus I to the 13th power. Express the answer in rectangular form. So that's the tricky part. So it says, use Adv Math's theorem. The first thing that you have to do is we have to take this and put it into the polar form. So the way that I do this is a little bit different. This, we just know it's 1 unit long, and it's going to be 1, now I forgot what I'm doing. It's going to be 1 plus I, so it's going to be 1 unit long and 1 unit high. So this is what we have here. So we know that theta is going to be 45 degrees. We know this is square root of 2, this is 1, and this is 1. Okay, so in polar form, this is going to be the square root of 2 CIS 45. Okay, so we're just going to take this and take it to the 13th power. So square root of 2 CIS 45 to the 13th power is square root of 2 to the 13th power CIS 45 times 13. Square root of 2 to the 13th power is 2 to the 13 over 2. CIS 45 times 13 is 585. So this ends up being 2 to the 6th and 2 to the 1/2. CIS 585. 2 to the 6th power is 64. So you have 64 square roots of 2, CIS 585. Now it's 585 is bigger than 360, so we have to subtract 360 degrees. So we actually end up with 225. So 64 square root of 2, CIS 225. And we have to take that and turn it back into rectangular coordinates. And the way that the book does it is it just says 64 square roots of 2, CIS 225 is equal to 64 square root of 2 negative square root of 2 over 2 minus square root of 2 over 2i. And with that, we know that that's negative 64 minus 64i. The way I do it is just a little bit different. Since you know that it's 225 degrees, I just came over here, 180, 225, I know that's 45 degrees, and I know that this would be 1, and I know that this one would also be 1. So 1, 1, square root of 2, and then since our answer was 64 square roots of 2, 64, we just multiply this by 64, multiply this by 64, multiply this by 64, and you get the same answer. You get negative 64 minus 64i as your rectangular coordinates. You get the same thing. Okay, so that was example 79.2.